This video focuses on probability of events. Probability is described as a likelihood or chance that something such as an event will happen. The rule for probability is probability, that's the P stands for, E for event, so the probability of this event happening equals the number of outcomes where the event occurs divided by the total number of outcomes. The probability of an event occurring is a number between 0 and 1. This number states precisely how likely it is for the event to occur. It must be written as a fraction in simplest form. So we're going to extend on probability of events here and look at probability of an event occurring. And we know that that is a range between 0 to 1. So let's break it down. I've broken it down here for you into a scale of 5 different possible choices. So it's out of 10 in this example. And if something has a 0 out of 10 chance in happening, it's impossible. That's like a unicorn flying into your classroom at school. That's never going to happen. And then if it's got a 2.5 out of 10 chance, it's unlikely. It could happen, but because the number's so low, it's unlikely to happen. A 5 out of 10 chance is half. It's even. It's a 50-50 chance. And it's also an equally likely chance. It's kind of like flipping a coin, heads or tails. A 7.5 out of 10 chance is likely to happen. The number is quite large on top. It's not a 10 out of 10, so it may not happen, but there's a really good chance it will, so it's likely. And the 10 out of 10 is certain. 100% it is going to happen, okay? So events like you'll have a birthday each year, that's certain, okay? So yeah, 10 out of 10. So now we move on to the outcome. An outcome, that's a possible result of the experiment, like rolling a 5 or a coin showing tails. So that's like the answer, the result. So we do something, like flip a coin or toss a die, and the answer, or what shows up, is the outcome. The sample space is the set of all possible outcomes of an experiment. Never repeat outcomes when listing the sample space. And so I've got 3 examples here for you. The first one's a die. So you roll a die, like on a board game. And because it's 6-sided and there's 6 answers, we list them. So our little squiggly brackets here, 1, 2, 3, 4, 5, 6, and close the squiggly bracket. You have to put a comma in between each one. If you have an experiment where you have a 12-sided die and there are 2 number 1s, 2 number 2s, 2 number 3s, and so on, you don't repeat the number 1 twice. You only write down what answers you can get, not how many of those answers you can get. The coin, heads or tails, again, squiggly brackets, write heads or tails and separated by a comma. And if you have a bag of marbles and you're selecting from the bag of marbles, you may have several red, several blue, green, and yellow, but you only list that once. You don't list 3 reds or red, red, red if you have 3 red marbles in the bag. You just list it once. Red, blue, yellow, and green, again separated by commas and inside the squiggly brackets. So 2 more words that we need to look at here are experiment and event. An experiment, or known as a trial, could be tossing a coin or rolling a die or spinning a spinner. It's the actual happening of the event. And the event is either a single outcome, like rolling a 3, or a collection of outcomes, like a 3, 4, or 5. Now we're going to actually look at an example, a question that we can work out probability answers to. So this spinner has 5 equally divided sections. You can see that you can get a 1, a 2, a 3, or a 7 on this spinner. So first thing is we're going to list the sample space. So we write sample space equals squiggly bracket. So we have a 1, comma, we have a 2, comma, we have 2 3s, but we only write 3 once, and we have a 7, and we close the brackets. There's our sample space. The second question here says find the probability of getting a 3. So we put P, open the bracket, 3, what we're trying to find, bracket equals, and fraction line. And the first thing we have to do is look at how many outcomes we can have. So there's 1, 2, 3, 4, 5. 5 outcomes. That's the 5 possible answers we can get on this spinner. And how many times we see number 3? We see it twice. So the probability of getting a 3 is 2 out of 5. Question 3 says find the probability of not getting a 3. So P bracket not 3 bracket equals. We know there is 5 possible outcomes in this experiment. And not getting a 3, there's a 1, a 2 and a 7. That is 3 numbers. So there's a 3 over 5 chance of not getting a 3. Now we move on to this question here. It says find the probability of getting a 3 or a 7. So P bracket 3 or a 7 bracket equals fraction line. We know there are 5 possible outcomes to this. And it's talking about getting a 3 or a 7. So we can have a 3 or a 7, and there are 3 numbers there. So it's 3 out of 5 chance. And the last one here says find the probability of getting a number that is at least a 3. So probability at least 3 bracket equals. There are 5 outcomes, and at least 3 means 3 or above in value. So we can see here there's 2 of those are 3s, and the 7 is greater than a 3. So there is 3 numbers out of 5 that are at least a 3. So what you need to understand here is that what goes in the bracket is what the question is asking you to find. What goes in the bottom is the total number of outcomes in the experiment, so how many possible answers we can get. And in this case, there's 1, 2, 3, 4, 5. And the number on the top is the answer to this. So in this one here, not a 3, there are 3 numbers that are not a number 3. In this case here, getting a 3 or a 7, there are 3 numbers that are a 3 or a 7. And over here, at least a 3 means numbers 3 and above. 1, 2, 3. There are 3 of them, which is why we have number 3 on top. Here's another example we're going to take a look at. It says a letter is randomly chosen from the word probability. Find the following probabilities. We've got 6 questions here. We're going to work through them and set them out correctly. It says find the probability of choosing an L. So P bracket L bracket equals fraction line. So we have to look at how many outcomes we have. There are 11 outcomes because there are 11 letters in the word probability. And there's only one L. So 1 out of 11. Question 2 says find the probability of not choosing L. P bracket not L bracket equals fraction line. And we know there's 11 outcomes. So 11 goes on the bottom because there's 11 letters in the word probability. And not getting an L, well, because we know there's one L, it means that there's going to be a 10 over 11 chance of not getting an L. Question 3. Find the probability of choosing a vowel. P bracket vowel, close the bracket, equals. And we know there's 11 outcomes because there's 11 letters. So a vowel is A, E, I, O, U. And there are 4 vowels in this word probability. So we write 4 over 11. In this question over here, question 4, it says find the probability of choosing a consonant. A consonant, is every other letter in the alphabet that is not a vowel. So everything other than A, E, I, O, U. So P bracket consonant bracket equals fraction line. There are 11 outcomes and there are 7 consonants in the word probability. Question 5. Find the probability of choosing a vowel or a B. So P bracket vowel or a B bracket equals fraction line. And we know there are 11 outcomes because there's 11 letters in the word probability. So there are 4 vowels and 2 Bs, which makes it 6 over 11. And finally, the last question here says find the probability of choosing a vowel or a consonant. So P bracket, vowel or a consonant. I'm going to run out of room here. I'll put it underneath here, equals. Normally that would be over here. Equals, and there are 11 outcomes. And if we're looking for a vowel or a consonant, that means every single letter there is either a vowel or a consonant, which equals 11 over 11. And underneath that, you simplify that fraction down to 1. So again, this should be underneath this fraction here. Don't work sideways to the right. Unfortunately, I have had to do that because I've run out of room. But you must simplify the fraction and it goes underneath. So 1 should be written underneath. So let's just quickly recap what we've gone through so far. So P stands for probability. E stands for the event, so what they're asking you to look at. So that's in between the brackets. The equals sign, the fraction. So underneath goes the total number of outcomes, the total number of possible answers that can be gotten or gained from the experiment. And the event outcomes is focusing on this, how many times that can be found or occurs in that particular experiment. Let's take a look at this example down here. So it says a bag of marbles contains, so we've got 15 marbles in this bag. We've got red, blue, green and black. The first thing it asks us to do is to list the sample space. So you normally would write sample space, but I haven't got much room here, so I'm writing SS as an abbreviation. Open up the squiggly brackets, and I simply list the 4 colours here. Red, blue, green, black, and close the brackets. So each word is listed based on the colours in here and separated by a comma. This question says, find the probability of drawing a red. That means getting a red out of that bag. So P bracket red bracket equals fraction line. I know there's 15 marbles in there, so there's 15 outcomes. And if I count, there's 1, 2, 3, 4. There's 4 reds. So a 4 in 15 chance of getting a red. This question here says find the probability of drawing a red or a blue. So P bracket red or blue, and you can actually write R or B. It doesn't matter as long as it's very clear for yourself and the teacher to see. And we know there's 15 outcomes because there's 15 marbles in there. And if I count all the red and blue, there are 7 red and blue marbles, so 7 over 15. This question here says find the probability of not drawing a green. So we don't want a green. So P bracket not a green bracket equals fraction line. We know that there are 15 marbles, so we put 15 down there. And then we look at counting all of the other marbles that are not green. So blue, black and red, and there are 10 of those. Now in this situation we have a fraction that can be simplified. So normally underneath, because you normally work down, you would simplify this fraction, but because I haven't got any room, I'm going to pop it on the side here. So if I break this down, the highest common factor is 5. 5 goes into 10 2 times, and 5 goes into 15 3 times. So we must have a simplified answer for every probability question involving fractions. And this last question says find the probability of, or choosing, missing a word, sorry, choosing a black, green or red. So P bracket black, green or red bracket equals fraction line. We know there are 15 marbles, so there are 15 outcomes. That goes on the bottom. And we're looking to draw a black, green or red. So let's count these over here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there are 12 marbles that are black, green or red. That's why we've left the blues alone. So we need to simplify this fraction, and 3 is the highest common factor. 3 into 12 goes 4 times, and 3 into 15 goes 3 times.